Well, welcome back everybody. In this video we're going to go ahead and continue our MPLS Layer 3 VPN section with our next topic, which is going to be using BGP to set up a IPv6 peering for the Layer 3 VPN connectivity so that our CE routers can propagate routes into the service provider network and propagate some routes. So one thing that we need to be understanding on how this whole process works is this is going to be what they refer to as 6 VPE, where we are doing 6 provider edge, but instead of a VRF, where 6 provider edge is in the global routing table and 6 VPEs in a VRF. Well, the concept that we need to understand is it has nothing actually to do with IPv or with the feature specifically 6 VPE. What it has to do with is the trace route capability for IPv6 in iOS 6.0 and later, I believe it is what it was. The trace route feature doesn't seem to work. I'm going to test that out, but I'm also going to set up a test peering here with CSR1 to R13. So we're technically going to have CSR1, XRB9, and CSR6 doing the peerings so we can validate R13 to R15 trace routes. But the trace routes, I don't know. I haven't actually done this yet. I don't know if the XR boxes are going to show up the trace route in the path. So we'll take a look at that as we're going along, but we'll get there when we get there. So we're going to go ahead and get this party started. The configuration is actually relatively straightforward. There's really not too much to do. We're going to start on CSR6 and do the configuration to CSR15. So we'll do a show IPv6 interface brief. We'll see that we have 101.615::6. So we'll go to router BGP 100, address family IPv6 VRFC1, and then neighbor of 101:6:15:15, remote AS of 15, and go from there. And then on 15, we'll go to global config router BGP 15. We'll type in address neighbor of 101:6:15:6, remote AS of 100, address family IPv6, and then we'll type in the activate command, and then the network of 10:1:15:0/64. Now with that, we see the peering has come up. We go into CSR6's routing table, do show IPv6 route VRFC1, and we should learn a BGP route, which we have. Now if we go up to CSR4 and we look at the show BGP VPN-v6 unicast all, guess what we learned? We learned a route through ::FF:1.1.1.6. This indicates that it's a VPN-v6 peering. If we look at CSR1 and we jump out of global config, show BGP VPN-v6 unicast all, we can see that it's being learned through a couple different routes. We expand this out and we can see that the propagation has occurred the way that it's supposed to. Now we're going to flip it and we're going to do this for XR. XR is a very similar configuration wise. Let's go ahead and jump on XR9. If I can type in the right password, will we get there someday? There we go. So we'll type in router BGP 100. We'll type in a VRFC1 neighbor of 101:9:14:14, remote AS of 10, address family IPv6 unicast, and then we'll do a route-policy of pass in and out. Now, one thing that I have to remind you guys about is the IPv6 portion of the VRF config inside of XR. Let's take a look at the current configuration of BGP on router or XRB9. And underneath the VRF, we only have IPv4 configured. So that means we're going to have to go exit out a couple of levels and add IPv6 unicast in. Until we do that, the peering won't actually come online. So we're going to go ahead and do a quick show config to make sure that all that is squared away. And we're going to go ahead and commit that config. And then we're going to go down to R14, log in here, router BGP10, neighbor of 101:9:14:9, remote AS of 100, address family IPv6, activate the adjacency, and then the network of 10:1:14:0/64. Now give that a couple of moments and we should have an IPv6 adjacency that pops up with XRv9. Remember, it goes a little slow. And if we look at the show IPv6 route, we should have a BGP route here momentarily. Let's see here. The peering is up. Show BGP IPv6 unicast. Okay, so it's still trying to do its figure it out stuff. So right now it's still doing best path selection right here. So once it's done doing that, we'll be okay. Because right now it doesn't know how to get to the next hop. So we'll have to wait for it to finish its calculation. And let me just make sure I include IPv6. Make sure I turned on IPv6 unicast routing. Pretty sure that I did. And I did. And so the problem we have right now is we're waiting for, because right now what's happening is, if you look right here, we're missing the greater than sign. Right now we have a valid route, but we don't have a best route. And so now there they pop in. So now if I do a show IPv6 route, now the 10.1.15 prefix shows up. Now if I ping it, ping 10:1:15:15, sourcing from loopback 0, I can ping it all day long. If I do a trace route, IPv6 to this guy, sourcing from loopback 0, actually, I should be able to do it this way. Trace route, and then all this sourcing loopback 0 numeric. Okay, yeah, that's the problem. I remember now. So it's going to be a trace route, IPv6. Target address is going to be 10:1:15:15. The source address is going to be 14:14. No, yes, I do want to do numeric display and go all the way down. And what's going to end up happening? Oh, so it does work in this particular case. So we get to the next hop, and then because we go through a XR box along the path, so we go from, so the path that we're taking is XRB to CSR2, and CSR2 is going down to XRB10. So if we were to do some mild traffic engineering, we should eliminate that possibility. So what I will do here in just a moment, once we get the other peering up to CSR1 to R13, we can do some traffic engineering to make sure that XRB10 is actually not used to forward traffic, and we go, regardless of what path we take, we don't use XRB10 and we don't use XRB11. We follow the path out CSR6. That's an option we can do internally for doing specific path engineering, but this right here, the XR boxes do not have, for whatever reason, they don't pass the ICMP messages and the trace routes. Like the UDP and ICMP messaging just doesn't translate. I don't know why. I've looked it up. You have to go back to 5.3 code on XR in order for this to work. So it is what it is. But we know that there's reachability because we can get end-to-end connectivity and stuff like that. So I don't know if there's a command in IP or in the XR platform to allow that to happen or not, but that's basically where that's at. So let me go ahead and get the CSR1 configuration up and running real quick. We'll get them squared away, and then we'll type in, I'll get the rest of the routing, we'll do the rest of the verification. So show router BGP 100, address family IPv6 unicast VRFC1, neighbor of 101:1:13:13, remote AS of remote AS of 10, or yeah, 10. And then we'll go over to 13, and we'll go to global config. Do show run pipe include IPv6. I don't honestly remember if I've turned IPv6 unicast routing on, but that definitely needs to be in play. I have. So router BGP 10, neighbor of 101:1:13:1, remote AS of 10, address family IPv6, activate the adjacency, and then network of 10:1:13:. Okay, so I'm actually glad this happened. Let's see where we're at, :/64. So what's happening now is we're getting a BGP notification. So what this is actually saying here is that we have a malformed packet, and we have the, where was it? The wrong, I believe it was the wrong AS. Yeah, appear in wrong AS. So what you can do when you're looking at something like this, if you're not sure what AS is supposed to be propagated, because I accidentally typed in remote AS is 110 when it's supposed to be 100. But right here, we take the last byte here. Let me go ahead and pull up the calculator real quick. Give that a second to calculator. There. So pull up the calculator real quick. And you have to be able to do this on the calculator. It's taking a second to load. So what will end up happening is here in the, I think it's the scientific. No, it is the programmer. Here we go. So this is in hex right here. So if we plug in hex, if we plug in 64 and we flip that over to decimal, it's 100. So this right here, the 64 that I'm highlighting, that is the remote AS, the remote BGP peer, telling you what AS he is in. So CSR1 is responding to R13 saying, I'm not an AS10, I'm an AS100. So if I come out, if I get out of here and I hit the up arrow and I type in this command right here, I just throw in a 100, that should fix the problem. Hopefully, maybe, Bueller. There it goes. So now my peering is up and ready to go. Give that a second, and there I'm at. So that's what you have to remember how to do. So that's why I went ahead and I showed you that demonstration, because this right here, the 64, the last byte in the output is going to be the appropriate autonomous system number on the remote end. So CSR1 responding to R13 saying, I'm not an AS10, I'm an AS100. So keep that in mind for future troubleshooting if you'd like. So there's that. So now if we do a show IP BGP, or sorry, show BGP IPv6 unicast, we'll see that now the routes are there. If we do a, for whatever reason, we're not learning 14. Let me see why we're not learning 14. Show run BRF. We should be learning 14. Show BGP VPN v6 unicast all. We're learning 14. 14 is not being visible from. So let's actually, this is a great troubleshooting scenario. Okay, so we should have full mesh of connectivity. R13, R14, and R15 should all see each other's routes. So R13 should see R14 and R15. R13 should see its route and R14's route plus R15's route, and it's not. So we have to figure out why it's not happening. So on CSR1, we're receiving the prefix from 9. But if we do a show IPv6 route VRFC1, we are getting the route, right? So we are learning the prefix, but when we go to 14 and we do a, I'm sorry, 13, and we do a, the route's not being propagated. Now, this is a great example as to what's happening here. It actually has nothing to do with our current configuration. Okay, what's actually happening, let me go ahead and I'll jump back out real quick. Debug IPv6, or debug BGP IPv6 unicast updates and inbound. Let me go ahead and drag this up a little taller. And I haven't actually discussed this yet because I haven't done any real major dual AS, or I should say having a single AS appear twice to the same service provider. I haven't gone over this yet, but I know exactly what the problem is. So the problem is, if I was to do a clear BGP IPv6 unicast star and soft but inbound, what we're going to see is, okay, perfect, right here. Let me go ahead and get out of the way. Look right here. It says received update about 10:1:14:/64 denied due to AS path contains our own AS. So what's happening is the eBGP loop prevention mechanism of I originate a route with my own AS, AS10 in the AS path list. I originate that route with AS10. It goes to the service provider, AS100. So 14 advertises a route. XRV9 receives that. XRV9 propagates that to its connected route reflectors, so XRV10 and CSR4. What ends up happening then is the route goes from 14 to 9, and from 9 to 10 and 9 to 4 via route reflector updates. Then 4 and 10 propagate those routes to 1 and 6 and 32 based off of its BGP peerings to via VPN BGPv6. So CSR1 is learning the route. We can validate that right here. It's learning the route. Look at the AS path. It's got an entry of 10 in it. If we look down here in the routing table, it's showing up. We know that it's being moved from BGP and it's being imported into the VRF. Now what's happening is when CSR1 goes to propagate that, R13 looks at it and goes, well, wait a minute, I'm in AS10. And we know that by looking at, where is it? It doesn't show me in this output. I'd have to probably do summary. Show BGP IPv6 unicast summary. Yeah, we're in AS10. Because we're in AS10, if we get any routes that originated in AS10, we're going to deny them, because that is a loop prevention mechanism. So I can do one of two things. The first one I can do is on the provider side, so CSR1, I could say, you know what, I'm not going to propagate the route that was originated to me as 10. I'm not going to propagate it out as 10. I'm going to swap it to be my autonomous system. So 10 would get replaced with 100, and then R13 would receive that route. Or I can go to R13 and say, you know what, I want to just like pretend like I didn't see that. I'm going to receive that route in anyway with allow AS in. So I want to allow my AS in for any routes that are being propagated to me. On CSR1 side, it would be AS override. Go ahead and replace your AS with my AS. So those are the two options. I'm actually not going to demonstrate them right now, only for the fact that I have specific use cases for that if we're going to be coming up later on. I'll be covering that for V4 and V6. But I wanted to at least call out why it wasn't working. Not that there was a misconfiguration. It's actually a BGP loop prevention mechanism that's causing that, and that's a good thing. We don't want to get route feedback, because what could potentially happen is R13 is peering with CSR1 in this particular case, which we know is to be true. Now CSR1 doesn't know if R13 is taking BGP routes that it's learning from CSR1 and then originating them back into an IGP here, maybe EIGRP, for example, which we happen to have right here. In an upcoming set of videos, we'll talk about route feedback and how you prevent that type of stuff with things like site of origin, allow AS in, AS override, things like that. So for the sake of argument, we're not going to do it, but just understand that if we wanted to receive that route, we could. With that being said, ladies and gentlemen, that is going to be the rest of our testing for this particular set of topics. We're going to move on to the rest of the configuration as we're going along. Until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.